And this is Brandon, this is Daniel. Yeah, super excited to have him from, National Weather Service, and if you saw our blurb, it's everything weather today. I hyped it up because I'm so psyched. So Daniel, to give you just a personal background, his son was on the soccer team that I coached for years, and Daniel and I struck up conversations 2018, 16, 17. I constantly was like, weather, everybody loves weather. You need to come and speak at our speaker series. And so then COVID hit, and so, but every time I saw him, every time his son came to practice, I'm like, how's your presentation coming? How's your presentation coming? How's your presentation coming? And so finally, this winter, we made the commitment, and we knew we were going to kick off the speaker series in March. And I'm really excited to have Daniel and Brandon as the first in the next round of the speaker series to be here. And I'll let them kind of tell you about their profession and their role and everything else. But it's super excited to have you guys. Thank you.
Thank you, Michael, and thank you guys for letting us come here and talk to you today. We're gonna move forward there. We're gonna break this up into kind of two different talks. Dan will talk after I complete, but I'm gonna introduce you to the National Weather Service. A lot of folks are aware of us, may have heard of us, may not have heard of us. So we'll do a little introduction on who the National Weather Service is, what we do, how we go about making a weather forecast, because obviously that's something everybody's interested in each and every day. You wake up in the morning, you decide what you're gonna wear. What do you base it on most of the time? What the weather is. You know, so something as simple as that. If you're traveling, the weather impacts our lives each and every day. So it's very important. And so we'll talk about how we make a weather forecast, how you can get that forecast, and then we'll talk about how you can support the National Weather Service. We're a taxpayer-funded organization. So basically, for about the price of a cup of coffee, depending on where you shop, that's about how much it costs to run the weather service every year. So it's a very valuable resource, and we're here to protect life and property. That's our mission. So runs very close to what you guys do here and what your aim is to as well. So what we have up here on the screen. So I used to work at a weather forecast office where we made the weather forecast. Last summer, the end of last summer, I jumped over and I now work at National Weather Service headquarters, aka the dark side, some people say. But I did for 8.5 years work at a weather forecast office. The picture on the left is the National Weather Service office in Key West, Florida. That was my first station of duty. And the one on the right is actually the one here in Sterling, Virginia, the local one that supports people who live in the Baltimore, Washington area. So those are kind of the two weather forecast offices I worked at. Prior to that, I met Dan, I think back in 2008, 2009. He helped get me a job as a contractor for the National Weather Service. Doing a lot of the similar work he's going to tell you about, so I don't want to steal his thunder, but it's a lot of instrumentation, testing, and verification for the Weather Service. So he'll talk more about that, but that's kind of the history with Dan and how I kind of got involved with the Weather Service. My educational background, I went to Millersville University up in Lancaster, Pennsylvania. That's where Dan went as well, but we didn't know each other back then. We met each other after the fact. So that's my educational background, and let's go ahead and kind of jump in here and talk about the Weather Service. So who we are. So the National Weather Service, you start at the top, we fall under the federal government, under the executive branch, so the White House. And under that is the Department of Commerce. Under the Department of Commerce is the National Oceanic and Atmospheric Administration. So that's kind of our mothership or mother agency, if you will. And under NOAA is the National Weather Service. So that's kind of the triarchy there, where the Weather Service falls. And as I kind of already alluded to, this is our mission. So the National Weather Service provides weather, water, and climate data, forecast warnings for the protection of life and property, and the enhancement of the national economy. So word for word, that is our mission each and every day. But really, in summary, it's the protection of life and property. A lot of folks that work for the Weather Service, that's really what our drive is each and every day, to make sure that our forecasts are as accurate as possible. We can get advance warning out to the public so they can take the necessary precautions to protect their life and their property. Weather impacts us each and every day, whether it's sunny and 75, or you have severe thunderstorms coming in, or we have a blizzard. That's going to impact the economy, and it's going to impact you each and every day. Thankfully, we didn't have any blizzards this winter. Had very little snow. Hopefully, I think most of the chances of snow are behind us, but we have had snow in April before, so I wouldn't count it out. So in summary, kind of how do we protect life and property? It's the watches, the warnings, the advisories we issue. But all the work that goes into issuing those watches, warnings, and advisories, you guys have to have a way to get that information. So that's also kind of what we strive to, is make sure you guys are aware. And we work with a lot of different government and private industries that I'll talk about here on getting that information to you. So, do a little overview here of the Weather Service. I kind of like this glacier or iceberg graphic here. So, kind of what you see each and every day when it comes to the weather and the weather forecast. You get it from the TV, the internet, either on your cell phone, a weather app. Private weather companies are pushing it to you. The radio. Does anybody in here have a NOAA weather radio, or just a weather radio in general? One hand, perfect. Hopefully after today's talk, I'll convince several of you to get one. They're very valuable, especially in the middle of the night when there's warnings that are issued. They will alert you if you need to take precautions. Particularly, we had severe weather last night, so down south, weather radio would come in handy. So you see that, you get your weather forecast, but there's really a lot more that goes into it. And the first thing that really goes into it is observations. And it's a wide range of things, whether it be radar data, weather balloons, surface instrumentation. These observations, I like to give an example of, it's when you go to the doctor and you get your vitals taken. You're getting your height, your weight, your pressure, blood pressure, temperature, all that. That's kind of what observations does for the weather and making a weather forecast. We got to know what the current state of the atmosphere is before we can make projections into the future. If we don't have a good starting point, that's going to impact things down the road. So observations are crucial to making a weather forecast and understanding the weather and making predictions. And then inside of that, those observations that we gather, they get siphoned out to various centers within the National Weather Service. Kind of there on the left side, we have the National Centers for Environmental Prediction. That's based College Park, Maryland, basically where we run our weather models. So those observations go directly into the weather models, simulations. We also have a Space Weather Prediction Center out in Boulder, Colorado. They also utilize that information. Our climate and seasonal outlooks as well. Aviation, Marine, the Storm Prediction Center out in Norman, Oklahoma. And of course the National Hurricane Center, which I'll show you is down in Miami, Florida. And then on the right side, kind of where I started my career, is the weather forecast offices. And then those offices, the one here in Sterling, issue the forecast and warnings. And then we have river forecast centers who kind of cover a bigger area that I'll show you in a second. They issue river forecasts, flood warnings, and that kind of thing. So there's a lot of groups here, but really all of them comprise together, not just within the Weather Service, but what you see on the output, what the forecast you see on the TV or on your cell phone, kind of all working together to provide the weather forecast and to allow us to protect that life and property that we talked about. So that's kind of what makes up the National Weather Service, all those various entities. So where and are they kind of all located and divided up here? There's a lot going on with the map. Those weather forecast offices I talked about, it's all those little red dots you get there on the map. The Weather Service itself is broken up into regions. So you have the different colored regions. The green region here is the eastern region, and then we have southern, central, western is kind of the salmon color. But we also branch out into the Alaska region, Pacific region, and kind of all over the place. We have these different regions. And then within those different regions, we have all those national centers. I mentioned the Space Prediction Center out in Boulder, the Hurricane Center in Miami. Aviation Center is centered out in Kansas City. Storm Prediction Center is there in Norman, Oklahoma. And then National Weather Service headquarters, where myself and Dan both work, in Silver Spring, Maryland. But also housed there just north in College Park is the Climate Prediction Center, Weather Prediction Center, the Modeling Center, and the Ocean Prediction Center. So there's a lot of centers here in the Washington and Baltimore area, kind of where Weather Service headquarters is centered. But that's kind of the breakdown of the different regions and all the various offices. There's a lot going on there. There's a lot of people that takes a lot of coordination to make it all work. But we have a really good team at the Weather Service and to really make this happen. So kind of going smaller, I talked about weather forecast offices. These are where all those forecast offices are. I got the red box highlighted there. That's the Sterling office. Kind of, and I'll talk more about the area that they covered there. But all the different regions there, the different colors, those are all the different forecast offices. And in total, there's 122 across the U.S., Alaska, Pacific region. So quite a few. Some are geographical boundaries, some are political boundaries, but it's really, there's a lot of work that goes in working with state emergency managers and kind of defining those boundaries and where the needs are. So that's, you're looking and you're like, those are some really funky areas. They're not boxes, they're just, some are bounded, along rivers and whatnot. Just kind of whatever makes sense for the people that live in those areas. But more about the local area that serves you guys. So the area highlighted in yellow here is the forecast responsibility for the Sterling Forecast Office in Sterling, Virginia. So it comprises of counties from Maryland, West Virginia, and Virginia. Maryland has 15 counties, 8 counties in West Virginia, mainly the eastern panhandle portion. And then Virginia has 22 counties with 11 independent cities. And of course the District of Columbia. All in all, there's approximately 28,000 square miles under their forecast area responsibility. So that's over 10 million people. That's quite a large area, quite a big responsibility. And you guys are well aware of the geography. You've got the Blue Ridge Mountains and the higher elevations to the west. Garrett County out there is a completely different world than further east. They got hammered with snow this year, and then further east, we were not as lucky if you like snow. And it extends all the way to the Chesapeake Bay and the tidal Potomac River. So there's marine responsibility, mountain areas, and then you have the coastal plains further east. So it really gives the opportunity to experience all types of weather hazards. It's very complex, and it's a very big area of responsibility. Moving kind of now to the hydrology, we mentioned river forecast centers. These are the areas of responsibilities for those river forecast centers. So the local area here is mainly managed by the Mid-Atlantic River Forecast Center. That is up in State College, Pennsylvania. So you can see they cover portions of New York, Virginia, West Virginia, Maryland, Delaware, New York, and New Jersey. Just to the west of the divide is the Ohio River Forecast Center, so kind of the western areas are managed by them. But these guys and these entities work with the weather forecast offices to issue their forecast, but they're responsible for issuing river flood warnings and whatnot to let you know if there's a risk of flooding. Here locally, the hydraulic area responsibility is broken up really into 3 main river basins. The Potomac, highlighted there in green, the Shenandoah in yellow, and then the Rappahannock there to the southeast of the yellow area. The Potomac area, or Potomac River Basin, is the largest in the local area with a little over 11,600 square miles. And along that river, there's 22 forecast points along the river that the Weather Service in Sterling is responsible for. And then the Shenandoah Basin comes in as the second there with just over 3,000 and 6 forecast points. So all those red dots you see are the forecast points that are issued out of the Sterling Forecast Office. Okay, so moving on from the hydrology, aviation. So aviation, in terms of the Weather Service, are managed by Center Weather Service units. The local one here is the Washington, D.C. CWSU, centered out of Warrenton, so not just right down the road. Those folks there do a lot of the aviation coordination with the airports, but the local forecast offices, like the one here, we do a lot of work with the main airports in the area. We got 6 of them there. So you got IAD is Dulles, DCA is Reagan National, you have BWI, MTN is Martin State up in northeast Baltimore, Charlottesville, and then Martinsburg. So those areas, the weather forecast offices issue called TAFs or terminal aerodrome forecasts, basically tell pilots what the weather is and what to expect over the next 24 or 36 hours. But the CWSUs there, they cover much larger areas, and they're coordinating kind of with the National Center out in Kansas City. So there's a lot of coordination that goes on between the national centers, these more regional centers, and then the local offices. But all in all, it takes coordination from all three entities to really get that forecast out to the proper people that need it. Now, I mentioned a little bit about the Marine. So the Marine area responsibility for the local office in Sterling covers the Chesapeake Bay, basically from the mouth of the tidal Potomac all the way north there, all the way up to north of Pools Island in Maryland, and then the tidal Potomac all the way up to Washington, D.C. So it's quite a bit of marine area there responsibility, and it extends all the way to the estuaries on the eastern shore. So a little more about the forecast office. You're wondering, okay, I hear about this forecast, who works there? Most forecast offices, those 122 we talked about, are broken down kind of like this. There's a group of management staff, so you have a meteorologist in charge, or AKA the boss. You have a warning coordination meteorologist who does a lot of work with local entities, emergency managers, kind of seeing how and finding ways to support them, providing our forecast information and any needs that they have. So they do a lot of one-on-one work with the community. You have a science operations officer. Think of the local trainer or your teacher for the weather forecast folks, and a meteorologist. And then you have an electronic systems analyst. We couldn't make the forecast and do what we do without somebody who's able to manage the systems that we're using, whether it be for observations or computer systems. It's kind of what the ESA does. In terms of operational support, there's an administrative support assistant, an ASA. There's an observation program leader, which I was briefly in my career for a little over a year. Manages basically the observation program and the collection of data into the forecast offices. Each office has a lead hydrologist who's responsible for the hydrology, the river forecast, and so forth. And then you have an ITO. Again, you mentioned a lot of computer devices and equipment that needs to be managed. The ITO is there to help with that. And then electronic technicians who help make sure that the equipment stays running and is working correctly. And then the folks that are really making the forecast, we have lead meteorologists, which usually comprise of a group of about 5 folks. So think of senior meteorologists or shift supervisors really is what their main role is in creating the forecast. And then you have support staff of about 9 meteorologists on staff at each office. These numbers could fluctuate, but typically this is kind of the core makeup of those forecast offices. So I mentioned a little bit about partnerships. So kind of the 2 main partnerships that the Weather Service has is with the broadcast and print media. They kind of act as the voice to get our forecast out, our watches and warnings out. So think of dissemination. And then emergency management. They're planning, response, and recovery. They're responsible to help keep our community safe. So the information we're providing work with really both of those entities. And it kind of all starts with you have a weather disaster. The most recent one was severe storms down south. So prior to that happening, we want to make sure we get advance notice out to the community so they can prepare and put themselves in the best position to protect themselves and their families. So if there's a chance of a weather disaster, a watch may be issued for planning purposes to let the folks know that this is the potential is here, this could happen, you need to prepare. But if it is certain and it's going to expected to occur, then that's when a warning gets issued. We work with the media and the EMs to get that word out. They kind of serve as the voice or the big microphone, if you will. The meteorologists you see on TV can reach a lot more people a lot more quickly than going to weather.gov or some of the other avenues that we have to get our forecast out. We put it out there, but working with the media really helps us get that broadcast out, especially here in the Baltimore, D.C. area. With as many people that live here, we can really get that message out through them very quickly. So those are kind of some of the key partnerships with the Weather Service. So I mentioned watch and warning. The best way to kind of explain this is usually the most confusing folks is, some folks say, well, we're under a winter storm watch. Well, what does that mean? Or severe thunderstorm warning, what does that mean? For you foodies out there, think of it like a taco. So when a watch is issued, we're basically saying the ingredients are there for something to happen. But when a warning is issued, that means taco's ready. We're having tacos. There's no ifs, ands, or a but about it. We're having tacos. So when you hear watches and warnings, think of it like that. I'm a big taco fan, so that's why I use this. Dan's got a sweet tooth, so we use the cupcake watch and cupcake warning. These are kind of easier ways just to visualize and think that when you hear watch and warning, think of these two graphics, and you'll it brings to light kind of what we want you to do. And then when those products are issued, there's details in it that'll tell you exactly what the actual watch is for, what the warning's for, and then you can take that information and prepare as necessary. Okay, so to cover watches and warnings and kind of what the Weather Service, who we are and what we do, how do we monitor the weather? So the first thing, and like I mentioned, compared it to going to the doctor to get your checkup, surface observations. We have to be able to measure the weather that's going on right now and understand it before we can make those projections into the future and issue that forecast. So surface observations can be buoys over the water. Kind of that middle picture there is an ASOS, which is an automated surface observing system. They're located at all the major airports. So they measure things like the height of the clouds, the sky cover, temperature, pressure, humidity, wind speed, wind gust. All that data is utilized to kind of produce these maps you see at the top. The one on the right is a surface analysis. There's a bunch of little numbers on there that are kind of hard to read, but they give you temperature, pressure, wind direction, wind speed. And then there's different various annotations on there where it's showing the front. There's a little blue line there going across Florida and off the southeast coast of the cold front. So using those surface observations, we're able to denote and figure out where those different boundaries lie. Because boundaries are very, very important when it comes to weather. And what we have over there on the left is what they're called METARs. I'm not going to try to pronounce that accurately, but that is basically taking those surface observations and plotting them on a map. So you can see there's wind barbs on it, so they tell you which way the wind's blowing, your temperature, your pressure, your humidity, and whatnot. All that's listed on those METAR reports there. So surface observations is kind of where it all starts. So we're measuring things from the surface up, but we're also monitoring from space down. And that's where satellites come into play here. So with satellites, and over the last 50 years have come a long, long way, and we're able to decipher a lot throughout the atmosphere with satellites. The picture there on the left is kind of the water vapor, so we're measuring how much water is in the atmosphere. Kind of your brighter red colors and orange colors is just your drier areas, and then your areas that are kind of more white is where you have the moisture, the clouds, and whatnot. So water vapor is very important. The upper right, we kind of have an infrared, so you have different colors denotes your cloud tops. So the brighter reds and the whites, those are your higher cloud tops. So you can see, I don't know when this picture was, but there's a tropical system there just south of Cuba. I'm hoping it's not Irma. I was there during Irma in Key West back in 2017. It doesn't look like the track it took, but so yeah, so that's kind of the infrared imagery, kind of tells us where those cloud heights are. Taller the cloud types, taller the cloud heights are, typically have more convection and potential for weather. So that's kind of where that comes in. And then the bottom right is what we call visible satellite. Think of it just taking a picture from the satellite of all the clouds down below. So it's simply the clouds over right there on the map. So giving you a visible picture of the atmosphere. So satellites are very, very important. So back on the ground, the Doppler radar, or the weather radar, that allows us to see a lot of what's going on, up in the atmosphere. But it's really, kind of helps us see, if you will, hail, rain, snow, sleet, winds, and even developing tornadoes. What they came out with about 10 years ago was dual polarization radar, and it gave us the ability to see those images there on the bottom left. Different variables that kind of let us decipher what the radar is seeing and the type of meteorological phenomena that's going on, whether it be hail, ice, those kind of things, and we can even see the size of the droplets within the clouds. So we can know if it's got bigger rain droplets, if it's the air is rising, developing thunderstorms. Radar really lets us see all sorts of things. And kind of here on the bottom right, so radar itself stands for radio detection and ranging. And what it does is basically the radar sends out radio waves, and once it sends it out, it kicks back whatever it detects, comes back to the radar, only usually a small portion. And that allows us to see what is being detected, based on the temperature and the height and everything. What's out there, whether it be hail, if it's snow, or if it's rain. So that's kind of how the radar works, and as it goes in a circular motion. Basically takes gets those pulses back, and it's able to decipher and give you the imagery you see down here of the radar data. So it's a pretty cool technology, and it couldn't do what we do and issue the warnings without the Doppler radar.
When did we develop that?
The dual pole or the Doppler?
Yeah, Doppler.
Boy, probably in the late 70s, early 80s.
Yeah, because the WSR 88D was one of the first ones, and that was 1988, but they had it before that. And I believe it was started with military. Was using radar, obviously, yeah. And it's developed over the years. The FAA has their own radars as well, utilized for aircraft. But the Weather Service, we have our own radars. And they're talking about, and we're in the process of upgrading those radars, because the current ones out there are the WSR 88Ds, 1988. That was a long while ago. So technology has improved, but it's not cheap to develop and deploy those new radars, but that is something the Weather Service is working towards. But they've been around for a while. Okay, so I'm not going to highlight this too much because Dan's going to talk about upper air observations, but we also take upper air observations with weather balloons, shown here in the upper right. We use instrumentation. There's one shown up there. There's a whole bunch of instrumentation over here Dan's going to talk about called radio songs. Essentially what we do is release these balloons. Each office does it twice a day. One's 12Z in the morning and one's at 0Z. That is Zulu time. So right now it is 7 a.m. and 7 p.m. they release these weather balloons. So twice a day at every office, at 122 offices at the same time, are releasing these weather balloons. And it gives us a snapshot of the atmosphere from the ground up to about 120,000 feet. So it goes pretty high before the balloon will burst and then slowly falls back down to the earth. So as it's going up, it's sampling the atmosphere every second and sending that data back down to a tracking system or a tracking station. And what it does, it gives us a snapshot of the atmosphere here, right here. So the red line here is temperature, and the green line is dew point. Where the lines get close together, that's basically saying where we have moisture or clouds. And where they fall apart, you got a lot of drier air. So that gives us a snapshot. We can get the winds all the way up to the top of the atmosphere. And then based on that, it derives all of these variables down here that takes many years of schooling to understand what they are and how they're derived. But Dan and I did it one day, but I don't know if we could do it anymore. But yes, upper air observations are key and crucial to making a weather forecast because it gives you a sampling of the entire atmosphere.
Is instrumentation recoverable, or is it?
It is, yep.
Do you oftentimes find it, or is there tracking? How is it just by chance that you find where it comes down?
We can track it. I would say, I know back 10, 15 years ago, we would maybe get, 20%, if that bad?
Like 20 to 30%.
A lot of them fall in remote areas or in the ocean. Many of the materials are biodegradable, so taking into consideration, Dan can show you.
Yeah, I was just going to point out that there's or you can look at this one, there's a mailbag on it.
Oh, so
You guys can actually pass it around, yeah. So if you found it, you could stick it in the mail and send it back. And it really depends on if the Weather Service has a contract with that particular instrument manufacturer if they will reuse it or and remake a new instrument at a discounted price to the Weather Service.
Right, I see.
Yeah.
What's the price of this?
They will range, I think, anywhere from around like maybe $100 to $150. Yes.
And they go 130,000 feet. I mean, a plane flies at 38,000,
Yeah.
32, 38, so it's that far above.
Yeah, they go.
Collecting.
Yep.
That's
The balloon you see there is about 6 feet across. By the time it gets to burst height of over 100,000 feet, it's about 30 feet. Because as it rises, the pressure decreases, so the balloon expands as it goes up. And the balloons are spec'd to go to a certain height. I believe this one's spec'd to go 26 kilometers. So once it gets to about that height, that's usually when it pops. And then the little orange thing you see there in the middle is the parachute. We still got this guy attached. So
That's a
it's-
heck of a balloon. How much does the balloon cost?
I think they're, what, they're about $50?
I think a little bit less.
A little bit less now?
Yeah.
The whole contraption, the parachute, the string that's used, the radius on is about $200, right? Yeah.
Twice a day, 120 offices.
122
So,
offices,
like,
twice a day.
Just 92 offices.
Oh, just 92, sorry,
Right.
forecast offices, yeah, 92.
And what's the propulsion? Is it just?
Hydrogen, most of them use hydrogen.
Uh-huh.
It was a mix of hydrogen and helium. Helium obviously got quite expensive, so most offices use hydrogen. Which does pose its own safety risk in terms of flammability to the folks that are obviously filling them, but a lot of safety precautions are put in place, safety measures to where it's not an issue, but it is much cheaper than helium. And we do have some offices that have hydrogen generators that can generate their own, so that does help save on costs too. Like I said, Dan will talk more about instrumentation observations, but these are a crucial part of making a forecast and getting an understanding of the atmosphere. So more about making the forecast. So forecasters analyze the observations, get an understanding of the current weather conditions. You got to know what's going on now before you can make projections into the future. That data and the observations is ingested into our weather models. The weather models run all these long, fancy equations, plug in the different components, and they get an output at the other end. So that's how we get those model solutions. It's taking, say, the weather balloon data, and it's putting it into those equations, and it's outputting. And we run different variations of those models, tweak a couple things here and there, just to see what the model output, how it changes. So that's why you talk about folks comparing the GFS, the European models, when it comes to tropical or winter storms, because each model tweaks things just a little bit differently. So you get all these different model solutions, and you can kind of take a consensus, and that helps improve the accuracy of the forecast when you have all these different solutions, kind of combine them, average them, and you kind of know what when you get into it long enough, you kind of know what each model biases are. So you can take that in consideration in a forecast. So models, they all have their different temporal and spatial scales, so that's why you get the different outputs, and you never rely on one model. It's usually a combination of models for forecasters. And they can range from mesoscale, which is kind of smaller scale, to more global, like the GFS model, the Global Forecast Systems, or the European, which is the EMC. And those models will give you a projection from today out to days or weeks. The forecast that we issue at the National Weather Service, our forecast goes out about 7 days. We will, if there's something in the longer term, might be mentioned it, but the forecast that's available on weather.gov is out to 7 days. Really, once you get beyond 7 days, the skill and the accuracy starts to decline significantly. So with our forecasters take a look basically how they perform, so verification stats. So the forecast that was issued and which models have been performing better, that's kind of what we use to kind of gauge our performance and how to improve. It's just like anything else. You may have, if you're a golfer, you go out and shoot 100. You didn't have a good day. Well, take a look at your scorecard and see where you can improve. Same thing with the weather forecast. If the forecast was a little off, your temperatures were too high that day, what happened? Did I look at the wrong model? Were there more clouds than I had expected? So forth. So we're always looking to improve the forecast. So with the forecast itself, local forecast offices will use what we call grids, and I'll show you a picture here in a minute. Those forecast grids are created and edited by using a software called the Graphical Forecast Editor. And some of those aspects of the weather that we forecast are all those different parameters there that we talked about, and many others that are not listed there. And this is what that GFE or the Graphical Forecast Editor looks like. So they got there on the left side is all those grids. Each one's a different weather parameter. You have temperature, your dew point, your RH, your winds. So each of those are individual grids, and they get tweaked and forecast. We can draw on these maps here and increase it, decrease it, populate in a model and see what that model is spitting out for a max temperature, combine them. It's all sorts of things you can do with this software. And it's really those individual grids is how the forecast is drawn up, if you will. And this is kind of what it looks like for those forecasters. And at the top there, we're kind of only showing a snapshot of, looks like 2.5 days, but it'll go out to 7 to 10 days. But the published forecast is only out 7 days. So you got those grids out through that entire time.
Is that automatically populated into the map?
Some of it is. Some of the variables, like the hourly temperatures, could you imagine doing an hourly temperature grid? So this is just for one grid, out 10 days, every hour. That's what, 10 times 224, so that's quite a few grids you'd have to do. So there is some automation to this. A lot of the offices use the National Blend of Models, which takes a combination of all the different weather models and gives you one solution. And that data gets automatically populated in, I think, every 3 hours. So that the newest MBM data will get populated in, and then the forecaster will go in and take a look at it and see if they agree with the output. If they don't, they'll make little tweaks. That's helped save some time in making a forecast because it can be very tedious creating hourly weather grids or temperature grids. So some of that is automated to an extent. But you can do snowfall and everything else, snow amounts. There's a lot in here. And kind of going through the forecast process, most forecasters work 8-hour shifts, but for most of those 8 hours, they're looking at model data and they're making these grids to output the forecast, which I will show you what that looks like here in a few slides. So the forecast, we make the forecast and we're going to present it and get it out. How do we get it out to the folks? So we talked about observations are collected, the data is QC'd and processed, goes to the modeling centers, is then outputted to the local offices. This bottom, the bottom picture down here, that's actually the local forecast office here in Sterling.
So I just want to point out that there are windows. That's not a dark room.
Yes. Most offices have small windows like that are kind of up above, and it's just enclosed with no windows. So it can be very claustrophobic. But some of the offices, like the Sterling office, has a nice big window display to the north, which I loved when I worked there because I could turn around and look and see the storms forming to the north or to the west. So it's very nice, but not all offices are like that. So it's not as glamorous as that looks to be. And then once local offices get that forecast, they create it and distribute it. Ways it gets distributed, we talked about media, the local TV media, NOAA weather radio. And then once that information is sent out, folks take it, emergency managers digest it. Is there anything that they need to respond to or prepare for? And then a lot of what we do, we issue that forecast is we get feedback from the public, from the emergency managers, from various entities on how our services help them. Was there anything we could have done differently? Was the forecast off? Those kind of things. We're always looking to improve, to make sure not only we're meeting our mission, but our partners are meeting their mission too. So it's a very collaborative process. So how do we communicate that weather information? A number of ways. We talked about broadcast and print media, the internet, NOAA weather radio again. There's a theme here. Private sector meteorologists, NAWAS is kind of a local, basically phone system with all the, here at the Sterling office, pick up a phone, you can get a hold of any of the federal agencies in the DC, Baltimore area. So that's kind of an immediate way if there's any local threat that we can broadcast over all their phones, any watches or warnings. Social media in the last 10 years has become a really big tool, particularly Facebook and Twitter, to get our warnings out and forecast out. And you can set them up for notifications on your phone, so it is very useful in that sense. The Weather Service, per se, doesn't have a weather app, but there are some government agencies that do, such as FEMA. I would highly recommend utilizing FEMA. You can set your location on that, and whenever any warnings or watches are issued, it'll alert you right away. Yes?
Well, I got two questions. Is that picture like actually real? The one on the bottom?
The one on the bottom, it is. It didn't happen all at once. It's, I think, what they call an extended exposure. So it took pictures, over, say, maybe a half hour, and just kind of combined all those images together.
Alright, and my other one is when was it?
When was that one?
Mm-hmm.
It looks like it has 2005 on it, so
Oh
yeah, it's been a little while, but it is a pretty cool photo. That's one good thing about living in this area and having as many people that live here. There's a lot of great photography, and you guys have some here as well. But there are a lot of weather-related photography or folks in the DC area.
And what about planes that fly probes right into tornadoes? That to me is just so incredible, both manned by a person as well as, I guess, drone probing.
Yeah, I hadn't heard so much about them going into tornadoes. We do have the hurricane hunters. They fly into
Well,
tropical
maybe it's
systems.
hurricanes.
Yeah, hurricanes. Yeah, tornadoes would be a very dangerous.
Yeah, but the hurricanes are too.
Yeah, no, they absolutely are. They're very hardy aircraft. I wouldn't have the stomach for it. So
Those are really long flights, so it's
Yeah.
not just like out and back. They're on there for like 9 hours
Yeah,
at least.
they're
Yeah.
incredible.
Yeah.
I read a little something about
Fun fact, who was the first one to do it?
Who was?
ooh,
I don't remember. Yeah.
Nash Roberts,
There you go.
became a famous hurricane out of New Orleans
okay.
forecaster. He actually accepted doing broadcasts for the local news, but he was the first one when he was in the military to do it. And then he basically set up his private business and worked with the oil contractors to give them forecasts. He became the most famous hurricane forecaster in the Gulf Coast. Nash Roberts.
Okay.
Interesting.
Yeah, it's not even just hurricanes or tropical systems. They now fly into winter storms. A lot of research was done with the atmospheric rivers on the west coast, flying into those systems. So yeah, that is certainly one way. And a lot of it is used for research, but when it comes to tropical systems, a lot of that is for the forecast. And
Now, could they use drones now instead of the airplanes, or do they have to have a live person in the?
I think they're using both. I think like an operational flight is still a manned flight, but I know there's research and private sectors that are trying to do drones.
And what they use is, in the airplanes at least, they use drop signs. So basically the airplane will fly up there and they'll drop instrumentation like we showed you, and then just have it drop through a hurricane. And it samples the same way a weather balloon does, except it does on the way down. So it gives them a snapshot of what's going on in the system as it flies over. So drop signs are pretty big when it comes to hurricanes. Sir?
Would you guys help with the drones and the planes that go into the hurricanes?
Yeah, so the forecast offices, at least in the local area, like in Florida, Miami, Tampa, a lot of them work a lot with those folks. But there are also either meteorologists or military personnel that fly in those aircraft. But we do work very closely with them. A lot of times we'll fly weather balloons in conjunction with the aircraft passing through, so we're getting all sorts of observations from surface up to surface down and so forth. So yeah, we do. And then actually, I have never put my name on a list, but as a NOAA employee, you can put in a request to fly on one of the hurricane centers.
Really?
So your name goes on a list, and you could get that call at any time. You just have to get to one of the airports to get on the aircraft, but there is that opportunity.
So there's always a NOAA forecaster, a meteorologist on the hurricane?
Yeah, a lot of those folks have a meteorology background and whatnot. Obviously, they're pilots too, but yeah, there's research personnel, scientists are on the aircraft. They're usually the ones dropping the instrumentation into the system and so forth. Yeah. So NOAA is, it's a big NOAA presence on those planes. Most of the planes are NOAA planes.
So NOAA had quite a footprint at Dulles Airport when you would come in Old Ox Road.
Yeah.
And now looks like it's more diminished. There aren't as many instruments as used to be there.
There is. Dan's going to talk about that facility.
Oh, okay.
But you're right. From 10, 15 years ago, there was a lot
Yeah.
more activity, but there's still quite a bit of activity going on there that you may not see.
It was always so exciting to drive
Right.
by it and
Exactly.
imagine what was going on with all those different structures.
Yeah, it looks very secretive, but trust me, 99% of it's weather related, so it is pretty cool. That's
No,
what-
just cool.
Yeah.
Not necessarily
Secretive or
clandestine.
anything, yeah. I think, and Dan has talked about this story, that ground used to be utilized for, wasn't it like a listening area or something?
Yeah, there's one end of the property that's no longer NOAA's. The rumor is that there was
Yeah, it's
like a
probably all the
DOD
traffic
property.
they tell us,
Yeah.
and now there's an emergency kind of area that's been set aside, but
Right.
it
Yeah, there's
just
a new
always
park
was
there.
so fun looking
Right.
at all that equipment.
Yes, sir.
Do you know that? Well, have you ever heard any stories from like a fellow coworker that you work with that's been on a plane?
I'm trying to think of somebody. Yeah, no, I went to school with some of the folks that have flown on them. Yeah, like I said, it's not for the faint of heart. It can be a very bumpy ride. But again, a lot of those folks, that's their passion. They love it. So I know some of the folks I went to school with that work for the agencies down there that do that. So, yeah. Any other questions? No? All right. Good question. All right, so getting that message out, I'm going to talk a little bit about how to get that information, those forecasts that we talk about. So this is our website, weather.gov. Weather.gov will get you to the main Weather Service website, but weather.gov/Washington or Baltimore will get you to the local page here, Sterling's local page, and it looks like this. So right in the middle in the front there is kind of the map and all the different colors, and it has a listing there of all the different hazards that are into effect. I think I grabbed this yesterday. So we had a flood warning out just west of Cumberland. There was a flood watch a little further west on the other side of the divide. So when you get to the page, it'll list all the hazards that are in effect, and you can click on them and get the information about those hazards. And then there's various other links down here. The staff usually puts out a weather story, kind of give you a snapshot of what to expect in the next 24, 36 hours. So it's very useful. You got your radar, your satellite. And then in the upper left up here is where you can put in, there's a little box up there for a zip code or a city. You can put in your location and get the forecast right for that location. So this is actually the forecast for this location right here. This was yesterday. So yesterday when I grabbed this, so it has this afternoon tonight. When you go to get the forecast, it has the graphics listed here. And it gets you tell you what the weather is, the temperatures, your highs, lows. And it'll give you a snapshot of the current conditions at the closest airport. So the closest airport to here will be the Manassas Regional Airport. And then on that page, a little further down, there's a detailed forecast listed here. Kind of gives you the text instead of the graphical aspect to it. And then there's a bunch of other links down here for additional information. And one thing I want to highlight on that page is there's a map here that you can zoom in, zoom out. That little green box is where that forecast is being issued for. So that covers this area where we are. But you can click on that map and click any location and get the forecast just for that. So remember those grids we talked about? You're getting a gridded forecast for that box right there, just in that small little area. So you can click, wherever you click, you'll get a forecast right from that grid, from the grids that we talked about. That's where that information goes. And if you want to know when it was last updated, it has all that information down here. So this one I grabbed, it was from 10:30 like I said, the forecast gets updated every 3 hours and pushed out to the website.
Are you gonna talk about the forecast discussion?
No, but I will, yes.
Okay.
But you can, if you want to get more information and kind of some of the technical analysis and get into the mind of the forecaster, if you will. During each forecast shift, the shifter is responsible for issuing a forecast discussion. So in that, they will discuss the different weather features, maybe what models they use for the forecast, so you can get an understanding on what they use to comprise it. It is more scientific and technical in nature, but the local forecast office tries not to get too technical, if you will. Because a lot of the meteorology jargon sometimes can be a bit much, but I think they do a good job at least explaining what they use for the forecast, what their thoughts are, maybe what their uncertainties are. You know, it's not an exact science doing a weather forecast, and they will portray that information to the public and say that this is where the forecast could go wrong, and this is kind of how we feel, and this is why the forecast is the way it is. Is there anything else with that you wanted to add?
No, if you want to geek out on weather talk, that's the place to go. It's like reading the weather tabloids.
Yep.
It's really cool. And it's when I was becoming interested in the weather, I would click on that in high school and like Brand said, kind of get the mind of the forecaster and see like, oh, I'm kind of uncertain about this, but you know, watching this feature for this time period, yeah, it's really interesting. It could also just be like a foreign language, like what Michael was talking about, whatever you were talking about in the beginning.
And sometimes they can be interesting. Having written many of those myself, I'll admit that my midnight forecast discussions weren't always the most coherent because it's 3:30 a.m. and everything else is going on. You're trying to get this out by 4 a.m. And that's one thing I didn't mention. The folks that are in the forecast office doing these work rotating shifts 24/7, 365. So there's 3 different shifts. They rotate on a week basis. So they're not working one shift for 6 months. This week they might be on day shifts. Next week they're working evenings. The following week they're working midnight shifts. And they can work anywhere from 7 to 8 days in a row before they're switching. So you can imagine what that does to the body and to the mind. But like I said, the folks that are creating these forecasts, they're driven by protecting life and property. It's their passion. So that doesn't really faze them. They just do it because they love it. But that is the life as a forecaster in the National Weather Service.
Well, I know everyone beats up on you and say that you're inaccurate. I think you're amazingly accurate.
We appreciate that, yes.
It's incredible to think.
It can be very challenging at times. I mean, it's easy to forecast something in 75, but when you get those complex weather systems, and you're putting together a forecast, and the phone's ringing off the hook, and you got NBC4 calling because they want to know what this means, and you can have a lot going on in a forecast office, but it takes a team effort. And I listed all the people that work in the office. We need each and every one of those all working together to make it happen, because it can get, especially during big snow events, you can just imagine how impactful that is to everybody in the area. So it can get quite busy. And you can imagine, you know, back when we had the derecho in, was that 2012, 2011?
I don't remember.
Yeah. Dan and I were both working at the Sterling Field Support Center at the time, so I wasn't in the forecast office, but those big events, it's, you know, a lot of times the offices will surge staff, so they'll bring anybody and everybody in that they can to support the need that day. So just a little bit more about the website, a little further down on that page, there's links to, you know, the radar satellite, different graphical, regional data there that you can see for temperatures or whatever, different parameters. But one of the things I like on the page is the hourly weather graph. It gives you a snapshot out a couple days, and you can even go even further in time of the different weather parameters, just so you can get like a snapshot of, all right, I'm going to go on a hike tomorrow. What's the temperature going to be? The winds? Is there a chance of rain? Absolutely love the hourly weather graph. I can just quick glance. So it's definitely something I recommend checking out. And once you go to the website and you get your location you're interested in a forecast, you can bookmark it on your phone or on your computer, and like, you know, Dan and I, or most meteorologists in the area, we'll wake up, have our cup of coffee, read the AFD, and then check the forecast. It's kind of just a routine of what we do. But you can do the same thing. So you can just click a link, and there you go. You got the forecast for the day. So while we don't have a weather app per se, the website is smartphone friendly, and it has all the information that we're providing. So the information is there. And we are working to improve the website too, so trying to advance with the technology. That should see some improvements here over the next several years. So how can you support your local National Weather Service office? There's a variety of ways. We have Skywarn Weather Spotters. So those are volunteers that are officially trained by the National Weather Service personnel to report severe weather, either by phone, email, ham radio. These classes are offered usually in the spring and then in the fall before winter season. But Weather Service meteorologists will go out to the different communities and teach these classes. And then once you go through, it's usually a 2 to 3 hour class. And by the end of the class, the folks that attended are certified weather spotters for the Weather Service. You get official ID, and so you're able to report the weather, what severe weather and whatnot to the Weather Service.
I'm actually one.
There you go. Perfect. Well, thank you.
For almost 30 years.
Okay.
When they started the program, I went to the Sterling office. I think they offered two, a beginner and then an advanced.
Yeah, there's a beginner, there's an advanced. They do severe weather, but they also do winter weather. I think they were looking at doing a tropical one too. So they're expanding the program.
And so since we're in the program, they have a phone number. The Weather Service has actually called the house on maybe 2 or 3 occasions in that time to warn us of some impending weather, just because of our location.
Okay.
I've never during the day at home, but several times my wife has answered the phone and the Weather Service is saying, you've got a pretty bad thunderstorm coming your way.
They want to keep you up and running.
Yeah, right. So we've basically the observations we've done has been after a thunderstorm, how much rain has been an inch, or we've had hail.
Yeah, a lot of times what they're looking for, and I've been the one on the other end calling folks like yourself when a storm goes over, is we're looking to verify our warnings to see if it reached severe criteria. So if we say issue a severe thunderstorm warning, the storm comes through, we'll be reaching out to contacts to say, hey, did you see any hail? Severe hail is a 1/4 inch or like size of a 1/4 or bigger. So we're looking for those type of reports. Any tree damage, if you have weather instrumentation and it's fairly well exposed, what kind of wind speeds did you see? Those kind of things.
Well, we got some requests too when they instituted the new radar. Around that time, because they wanted to know, I guess, if the radar observations were accurate with the local observations.
Yeah, that is important information to know. There's actually an app that I use every day. It's called MPing, little m and then PING. And basically what you can do with that is you can report what weather you're seeing at your location. So then it'll plot on the map, and then the forecasters can look and say, this person's reporting rain, or this person had hail to this size. And so that kind of helps us match up with what we're seeing on radar and what the observation at the ground is. Because the radar is shooting up to the sky, so we're seeing what's in the atmosphere. We can't see what's happening on the ground. That's why weather spotters are so important, is to kind of give us that ground truth.
Well, I don't know, I would encourage, one of the nice things is that we got to take the class at Sterling.
Oh, at the office?
So we got to go in and have a tour, so that was as much.
Yeah, they haven't. Well, I got there in 2017, and we had never had any classes in the office back then.
I think they changed it.
Yeah, they changed it.
Early on, and so we
A lot of time we're going out to the communities
Right.
to meet the folks, but it'd be nice if they could have it back at the facility again and give the
I
tour.
think there's a reporter either on Bull Run Mountain somewhere or Hopewell Gap.
Okay.
Because when you go on your weather, station, or app, whatever it is that I go
Website.
on my phone,
Yeah.
it has actually a locale either in the Bull Run Mountains or Hopewell. Do you know what I'm talking about?
Yeah, I've
There's
seen
one
it,
somewhere
yeah.
right here. I just can't remember if it's Hopewell Gap or Bull Run Mountain. I don't know who the individual is, but it's
We-
a pin that isn't Manassas Airport.
Okay.
Yeah. so
We
it's-
do utilize private weather stations. We look at that like Weather Underground and other entities. We'll look at the data, but in the back of our mind with the caveat is we don't know how it's sited. You know, do they have their rain gates installed under the gutter, that type of thing. So we kind of compare and do a source comparison of all different observations to see. But we do use private weather instruments that are available online.
Do you get a cool badge with that logo?
Oh yeah,
on it
and
if you're a
it's
Skywalker?
worn out now. I don't have a badge, but I have a card.
Yeah.
That's a
And
nice
they gave us a
logo.
bumper sticker that looked like that.
Yeah.
Since lost.
No, they still have them.
And actually a T-shirt. I mean, it's been so long ago.
Sure you get it up.
Especially once you get further kind of west of the Blue Ridge, there are some areas that the radar is blocked because of the mountains. So that's where spotters like yourself really come in handy, because we can't see what's going on down there. We can see what's going on up in the atmosphere, but that doesn't mean what's happening at the ground. So that's where spotters are very vital to the process. We do have cooperative observers, or co-op observers. So basically they're individuals that are provided equipment from the Weather Service to measure temperature, snowfall, rainfall on a 24-hour basis. So every day at 7 a.m. they take a weather observation and submit it to the Weather Service. And some of the equipment is shown down there at the bottom, is temperature sensor, display. And they're kind of situated throughout that little forecast area we talked about, usually in about a 25 to 30 mile spacing, just so we can get a sampling of all the different areas and the different climate regions and what the weather is and what's going on there. So cooperative observers are another big part of how folks like yourselves are supporting the Weather Service. And then amateur weather radio operators, during big events like the Duratio, where the storm system come through and knocked out power to thousands of folks. Amateur radio operators were crucial in relaying storm damage information to the Weather Service and to other folks across the area.
Something like Dulles Airport, would they have their own facility to test the weather right there, or do they rely on you all to make the prognosis for the pilots?
Oh, they rely heavily on us. Forecasts are generated just for that airport out of the local forecast office. They also hold daily conference calls with the airport operations folks to give them a heads up.
Is it with you exclusively?
Yep.
Okay.
Yep, with us exclusively. Yep. And they also, during the winter weather, they also support Reagan National as well to that extent. But most airports have their own weather observers or instrumentation folks that monitor the weather observations there. But in terms of the forecasts and projections, they come right out of the Weather Service. It's a nice relationship that we have with the FAA. And there's actually Weather Service personnel, meteorologists, that are staffed at all those CWSUs they talked about. Usually 2 to 3 folks are there. So they are face-to-face providing support to the FAA folks. So if there's storms coming in and they need to reroute aircraft, Weather Service is directly involved with that. Again, it's a big partnership with a lot of different agencies, a lot of moving parts. One other avenue you can support the local Weather Service is CocoRoz. It's the Community Collaborative Rain, Hail, and Snow Network. And really all it is this little rain gauge right here. It has a funnel with a measuring tube in there. But you can report your daily precipitation, rainfall. They have a nice little app. You just go on, put in how much rainfall you got in a 24-hour period. That data comes in directly to the Weather Service and other entities that can use that as well for their purposes. And you can report snowfall as well. So CocoRoz is another partner with the Weather Service that provides important observational data for us. So with that, there's a Weather Ready Nation initiative that started, I think it was in the early 2000s. And really what Weather Ready Nation is going out and reaching out to different groups and entities within the community and giving them, talking with them and letting them know how to get our forecast, how to prepare, so they can get their groups prepared, so they can get advance notice, how to react and what to do with that information that we're providing. And if they're able to do that, then they're considered prepared. And when we go out and have those talks with the different individual groups, they become Weather Ready Nation ambassadors. That's kind of the title we give them. So really the whole goal of the Weather Ready Nation is make sure that our nation is weather ready. So this is a program that the Weather Service is a part of, and is very important just to kind of expand our outreach into the community to make sure everybody is weather ready for any disasters, weather disasters that may come. So just wanted to highlight that. And with that, that is all I have. I will take any questions, but I do have a video here. This is when I was out on vacation in Denver back in the end of July. I was driving down the road and they had some thunderstorms, and I saw all this dust in the air, so I pulled off to the side of the road. And sure enough, it was a spin up of a small tornado. And you can see and watch it, you can see that it's actually turning and it's picking up a lot of the dust. I didn't see a ton of debris, but it was very dry out there at the time. But there is multiple vortex in there that are spinning and picking up a lot of that. And they issued a tornado warning for it. It's not your typical tornado. Most tornadoes are formed with supercell thunderstorms. This one was kind of formed off of, there was a thunderstorm nearby and it kicked what we call a gust front. So it's like a push of cold air came out and it helped spin up this little tornado like this. But it was still potential for damage, so they issued a tornado warning for it. But this is my one and only real tornado that I saw in person. I'm happy. I was on vacation, but it found me anyways. But yeah, so I thought that was pretty cool. I'll stop there. Does anybody have any other questions?
Sure, I have a question.
Yeah.
What's your biggest mystery or something like you couldn't explain that you've encountered?
Weather-wise?
Yeah.
I have to think about that one.
Like, what's the frequency of like oddball effects?
I found working in the forecast office and answering a lot of the phone calls from the public that we would get a lot of interesting observations from the folks, and, something that maybe we weren't expecting, weather spotters that would call in and report something, and looking at radar and satellite that maybe we weren't quite expecting. There always seemed to be something, but I can't pinpoint one exactly that would be an oddball. You got anything, Dan?
I'll have to think about that one.
Yeah, that is a good question.
She's stumped you.
Yeah. Yes, sir.
So, when you turn on the media, the television, radio, and they give a weather forecast, I'm taking it that whoever's delivering the forecast is basically being informed by the National Weather Service, or are they using private forecasting?
I'd say it's a mixture of both. All the warnings that are issued, the watches, that comes from the Weather Service. The Weather Service is the only entity that can provide that. That is something that the federal government has stated. You got to have one trusted, reliable source. So private companies can issue warnings. They can work with private groups to give them a heads up on things, but when it comes to official watches and warnings, that's strictly from the National Weather Service.
Okay.
Now the TV folks, a lot of them are degree meteorologists, so they can make their own forecasts.
Okay.
But a lot of them start with observations, are using NOAA data because it is provided free. So a lot of them, their forecasts start with the Weather Service, and they're being the voice of our watches and warnings. Some of the bigger TV folks have their own radars too. They're not as powerful as what the Weather Service uses, but I know some of the NBC and those folks in DC, they have a smaller version of their own radar.
Could you explain in layman's terms what dew point means?
Dew point is really essentially the measure of the moisture in the atmosphere.
How is it different from like relative humidity? Or is it basically the same kind of thing?
It's related. One of my professors had a big pet peeve of, saying that, hey, it's really humid outside. The RH is 90%. Well, you can get a 90% RH in the middle of winter. A 90% RH in the middle of summer is a little bit different. It feels a little stickier. But I always look at the dew point when I'm registering or thinking of humidity. So when you get dew points starting creeping up in the 60s, low 70s, it feels very humid.
So that's a better indication of how you feel.
Exactly.
Okay.
Yeah, exactly. And when it's closer to the temperature, you know it's quite humid. So if it's say 70 degree temperature and 70 degree dew point, your RH is going to be 100% because it's just calculates those two variables. But the dew point, my opinion, is a more accurate way of saying how humid it feels and how much moisture is in the atmosphere. The RH is just the percentage of the temperature and dew point variables.
So the higher the dew point, the more sort of uncomfortable
Yeah.
you're going to be.
So I was out a couple of days ago going for a jog on the C&O Canal, and the dew point I think was up to 59, and I could feel a sense of humidity. I think the temperature was 72 at the time, so 72 over 59. But 59, when it starts to get into the low 60s, you start to feel that humidity. Tomorrow I'm going to the Keys, and the dew points down there are in the upper 60s near 70, so I'll definitely feel it when I get down there. But yeah, dew point is definitely what to look at when you're thinking of humidity and how much moisture.
Final question. I see you had the Climate Prediction Center
Yep.
as part of the NWS. Is that the only federal agency that deals with, say, climate issues or climate policies as part of the National Weather Service? Or is there a separate, how is climate policy informed, basically, here in the United States?
So the Climate Prediction Center is kind of responsible for issuing seasonal forecasts, climate outlooks, weeks and months, seasonal outlooks. And those folks are climatologists, could have a meteorology background, but they're looking at the data and issuing those forecasts on these larger, longer time scales. When it comes to policy, that doesn't really come, that's more of a...
Yeah, NASA will also put out climate reports.
NASA. Okay.
Yeah, so I think recently they both put out, NOAA and NASA both put out a climate report. And as far as what guides policy, I don't know if one has more weight than the other.
But things like flood resiliency over the long haul, is that something that the National Weather Service would get involved in, or do you think with NASA, or is there any kind of cohesive entity that deals with that?
So they work, Weather
a little
Service...
off topic, I realize.
No. No, it's Weather Service works closely with emergency management. When you're talking about flood resiliency, that's emergency management's about preparing, in the future, sea level rise. So emergency managers are kind of on that forefront in terms of preparing down the road. But a lot of that, of what is expected to occur, is based off observations, seasonal outlooks, those kind of things. So they really work together in those aspects.
Yeah, I would say there's probably, depending on where you are and what type of environment you're in, there's also like the Army Corps of Engineers that would be involved in that sort of thing.
Yeah.
And then out west, there is, there's two organizations that are both escaping. The BLM may have some part of that, but there's also another one that's specifically out west that talks about like how water moves.
Right. I've always thought of the National Weather Service, or as weather, just in general, as being sort of maybe short to intermediate term in nature, and then climate as being, more longer term, patterns, etc. But I was just curious as to how the NWS interacts with other agencies to develop, climate policy.
Yeah, the Weather Service isn't directly involved in developing the policy, but we're providing the data and the forecasts that need to be used and considered when they're creating that type of policy. So the Weather Service, is directly or indirectly involved.
And if you remember, like one of the first slides, it was like White House, Department of Commerce, NOAA, and Weather Service. So at the NOAA level, there's a lot more climate monitoring.
At the NOAA level,
Yeah.
okay. Agency level. Thanks.
Yep.
You were speaking earlier about the radar being upgraded or updated at Sterling. I don't care about that, but how many of those radar stations are in the United States? So do they overlap, and is that how you get a national radar picture when you look at a radar map and expand it out? You know, is that,
I don't have the exact number, but yes, they do overlap, and they were strategically placed to make sure that all areas get covered to some extent.
so there's no dead area really from the locations now? I mean, it picks up.
For the most part, there are areas that get better coverage than others. Like I said, you could have beam blockage because of mountains, but they tried to place those to where that would be minimized. But also you have structures that are being built too that can cause interference as well. So where you have tall skyscrapers. One thing some offices have to deal with is interference from wind turbines, because they're sitting up 300 feet in the sky. So the radar is going to pick that up and come back and show a reflectivity from the wind turbines.
Also, just for perspective then, what's the closest one to the Sterling? Where would be the next one? Are you familiar with where that would be?
Yeah, so you've seen the one right next to the Sterling office.
Right.
The next closest one, there's one in Blacksburg, Virginia. There's one in Dover, Delaware, Wakefield, Virginia, State College, and then Pittsburgh has one up there as well.
So they're pretty spread out then. They
Yeah.
cover pretty good. Okay.
Yeah, I mean, they can cover, a couple hundred miles. So they have pretty good coverage. But as the beam goes out, it kind of goes up in the atmosphere. So the radar we get here, from here, we probably can see just a couple hundred feet up off the ground. But you go out to Garrett County, and it's shooting up 6,000 to 7,000 feet in the sky. So that's what it's sampling out that high, because it increases as it goes up, just because of the curvature of the earth. So that's something that has to be considered. So sometimes Pittsburgh's radar has a little bit better view of the storms coming across the mountain than, say, the Sterling office would. So the forecasters, they have what they call MRMS, multi-radar something sensing. The word's missing. But basically it takes all the radars at once and combines that data
Okay.
and generates an output. So they're able to consider all the different radars. So MRMS is actually very valuable to forecasters, especially radar warning meteorologists. Yeah. Yes, sir.
So this is more of a personal question. Both of you. You're off one of your 7-day stretches.
Yep.
Day off. You checking the forecast? You checking the weather?
100%. Yeah. No, it's the thing that most meteorologists will tell you. It's not a job; it's a hobby. So, we get to come to work and we get paid to enjoy our hobby. So even when we're off, we're looking at the weather forecast, seeing what's going on in the office, how our colleagues are doing. Maybe they need help. Maybe they need the surge staff. So weather is one of those things. Some people say they turn it off, but they just don't. It's a passion. It's tough to do. And usually after a 7-day stretch, I'm recovering that day, but I'm always in tune to the weather, because I have family that would call and say, "I'm going so and so. What's the forecast? When's it going to rain? When can I go hiking?" That kind of thing. So, but yeah.
So did it start when you were a kid? Did you like storms or?
Yeah, I blame my mom for this one, because she would always have the Weather Channel on the TV. But I think I really fell in love with the weather back in 1996 when we had the 96 blizzard. I don't know if some of you guys remember that. I know in Hancock, where I'm from, had 3 feet of snow. And then it wasn't even, a month or two later, we had a massive flood. The Potomac was flooding, all the basins were flooding, because we had all that snow on the ground, and then we had 2 inches of rain, so it all melted. So I remember, that winter very well, of all that snow, stacked up high, and then helping the local library up there move books out of the library because it was going to flood. So that struck me pretty young. I think I was 11 years old then. So pretty much ever since then, I was pretty much in tune to the weather. And I started issuing or giving the daily weather forecast at my school. I'd go on the intercom every morning and give a forecast.
Nice.
I did that all through high school, so yeah, I loved it.
Well, that was half.
Yeah.
I'm in a phase of my life where I like to be surprised by the weather, so I'm really not paying attention to it at all.
I can relate to both of those comments.
I will say, since I've left the forecast office last August, I don't look at the weather as much, because it's not the day-to-day weather. I kind of know what's going on, but it's not directly related to my current position. So I have taken a little bit of a mental break now that I'm at Weather Service headquarters, but it's still a passion and a hobby, so I'll never never not know what's going on with the weather, that's for sure.
Love it.
Yep. Thank you. All right. Any other questions? I'm gonna kick it over to Dan here. He's gonna talk about instrumentation.
Should we keep plowing through, or do we need to take a break? Okay. Let's plow. All right, 30 minutes. We can go. Okay. So my path to being where I am has I was probably about 9 years old when I first had maybe just a curiosity about clouds, and then similar to Brandon, like the Weather Channel was really coming out then, and seeing the impact of weather on storms was also really interesting. So it grabbed my attention, and there really hasn't been any turning back since then. In college, I think I realized that I wasn't really on a forecaster path. One of our professors liked to do boundary layer experiments and atmospheric composition or chemistry experiments. So the boundary layer is the lowest boundary, usually about 1 kilometer off the Earth's surface, from the surface to a kilometer, because there's a lot of unique interactions, especially with pollutants that are moving through the atmosphere. So one project that really kind of put me in the right direction was we took a farm and a barn, and we put a tethered blimp on the farm, and we would raise it up to about 500 or 600 meters and hook instrumentation onto it that would get all the different atmospheric variables. And everything about that project was really interesting because you had, in order to do this with the blimp, helium is super expensive, so you didn't want to deflate the blimp every time you did a sounding. So we'd go and take the blimp into the barn. In order to take a blimp into a barn that has a lot of sharp objects in it, we had to tarp the entire barn. So the roof was probably like 30 or 40 feet high, and so as a college student, over winter break, we're tarping all the way around this barn, and we're making rooms out of like styrofoam insulation so that we can put our instrumentation in it. And so the idea of setting up experiments was really exciting to me. And so that's kind of where I landed with instrumentation. Is I feel like it's right up my alley, and I really love what I do. So that's kind of my brief introduction. So I'll kind of go from a high level and then kind of drill down to exactly where I work and what I do. I work in the Office of Observations within the Weather Service. So Brandon mentioned that there's a lot of things going on behind the scenes in order to make that forecast, and the Office of Observations is one of those groups. So they're looking at anything from satellite data to radar data, surface observations, weather balloons, and buoys. And I'll just read their statement: responsible for the collection of space, atmosphere, water, and climate observational data owned or leveraged by the NWS to support the mission of providing weather, water, and climate data forecasts for the protection of life and property and for the enhancement of the national economy. So that mission, life, and property is a theme throughout all offices in the Weather Service. Extent of the observations portfolio. So we operate, maintain, leverage, and purchase a broad range of observing platforms, capabilities, and data, serving as a key component to a Weather Service mission. One of the areas that I'm not super involved in is the purchase of a broad range of observing platforms. Purchase of data. That says platforms, sort of involved in that. But there's also data buys that the Weather Service will do. They'll go buy private data. That's not in my area. However, surface instrumentation, upper air, and some climate monitoring is part of my area of expertise. This diagram here kind of shows the different areas of the Weather Service. It's similar to what Brandon showed for the iceberg picture, with observations being kind of at the base of the pyramid. And the highlight of this graphic is the impact-based decision support services. And so that is what Brandon talked about with getting the forecasters out with emergency managers and the public. Our former director, when he used to talk about IDSS, he would show a comparison of a tornado outbreak in the 1970s and then one that happened in 2011. The number of tornadoes, the severity of the tornadoes, the number of people that died, the damage was all very similar. And so the outcome of that kind of comparison was, well, what's going wrong? Like, why we've spent all this money to develop all these forecasting tools, we're giving the forecast, and the problem was the last mile. And the last mile is getting the information and communicating that information to the right people. And so in the last probably 10 years, this effort for the IDSS has been a major change in the Weather Service and how they do their business. Yeah. All right, so from the Office of Observations, there's radar, there's buoys, and then there's my division, which is the surface and over air division. So now we'll drill into that. All right, another lengthy statement here. Manages the development, operations, and maintenance of the extensive network of NWS surface and upper air systems and observational data procurements. SUBAD consists of program management, services, evaluations, and logistics management branches. It also includes the National Reconditioning Center, the National Logistics Support Center, and the Sterling Field Support Center. So evaluations is the branch that I work in, and the location is the Sterling Field Support Center. So here's the three main programs that we support. There's some other ancillary programs, but these are sort of the three. ASOS, which is the Automated Surface Observing System. That's what you would see at airports and helps with the aviation observations at the surface. Co-op, that's the one that Brandon was talking about, where you can host a weather station in your yard and take records. The name of the game for co-op is the longer the record, the better. So they wouldn't want you to take a station in your yard for just a year. That has a history of it being passed down through generations and families. So that's an important program. And then upper air is the sort of exciting one. And all of these observations serve as ground truth for other atmospheric observations. So for example, a satellite will calibrate its temperature imager with a paired weather balloon. So a radiosonde, we call them in situ measurements because they're physically coming in contact with the atmosphere, has a very high accuracy for temperature and humidity measurements. And in order for an imager from a satellite to kind of calibrate itself every once in a while, they'll pair that with a radiosonde measurement.
Excuse me, what's the National Reconditioning Center?
Yes, so it's just sort of like supply chain type stuff. So anytime a sensor fails, it'll get sent back to the National Reconditioning Center. It'll get reconditioned, hopefully repaired, recalibrated, and then sent back out for operational use. Similarly, the Logistics Center, if somebody needs to get a new computer, they'll get it at a Logistics Center, or a new, or if you need a box of weather balloons, you'll order that out of the Logistics Center.
So Dan, in addition to temperature, things like that, you mentioned pollutants. Does the instrumentation cover things like particulates or other types of sensing equipment for various pollutants?
Yeah, so for what we collect for the Weather Service, it does not. It's mostly temperature, humidity, pressure, wind, that sort of thing. I'm trying to think of, as far as like an operational pollutant monitoring observing system, it'd probably be within the EPA. There may also be some things at the higher NOAA level.
So for things like acid rain, like you rely on like a partner to kind of predict?
Yeah, I mean the Weather Service isn't predicting that sort of thing, but the EPA, I'm assuming, would be where you'd find that information out.
So the primary purpose of the instrumentation is to inform the forecast, basically.
Yes.
Okay.
Yeah. mentioned kind of the programs on the left. The only two that I haven't mentioned are the CHUAS network, Cooperative Hurricane Upper Air Station. So through an agreement from country to country, the U.S. will fund stations around the Caribbean to take upper air observations, and that's obviously significant for hurricane season. They will typically just do one flight per day, not in hurricane season, and then during hurricane season they'll ramp up to 2 flights per day. And then the voluntary observing ship program, that is sort of new to me, and just as it became new, it went back. I mentioned there's a data buoy center, so that's a program that's kind of gets moved around a little bit. I think it's back at the data buoy center. The idea behind that is that marine observations are far and few between, and as we try to make forecasts further out in advance, what is happening over the ocean becomes really important, and there's just not a lot of ground truth data out there. So at our facility we have a lot of test resources that I'll show you, but we hosted one of those observing systems that was supposed to go on a ship, and we tested it to see how well it performed. While these pictures are here, I'm trying to think of, okay, so this picture here, I don't know if this will come up again. This is an automated balloon launcher. Right here are banks of hydrogen cylinders for the balloon. Out of this little tube here, a balloon will fill up and be launched. So the idea there is, since it's automated, to take a person away from having to be there at real early in the morning, real late at night, from taking an observation. So there are 21 of these in the US.
There's the closest one here to here.
The closest one to here that is operational is going to be Detroit. Yeah, we have 2 of them at Dulles, but they're not operational. They're just for us to play around with. Okay, so if we zoom in on upper air, as Maria mentioned, I was going to cover a little bit more about that. So I have some things for you to kind of look at. Here is an example of a weather balloon. It is made out of latex, so I can pass this around. If you have a latex allergy, then probably don't want to touch it. So an observer is going to take this out. They're not going to touch it like I'm touching it, because our hands have oils on it, and as this the latex expands as it goes high up in the atmosphere, those oils are going to create weakness in the fabric. So the only place that an observer is going to touch is around the neck of the balloon. This neck is going to get stuck on top of a nozzle that's going to be connected to a helium or hydrogen tank, and it's going to be inflated. And they're going to know that it's inflated to the right amount by how much lift it has. So the nozzle will be connected to a set of weights, and based on their typical ascent rate, we're looking for like a 300 meter per minute ascent rate, or if there is some precipitation or snow, we'll add some weights to it so that it can get through that layer of snow and precipitation. So yeah, they're going to stick this on the nozzle, they're going to turn the gas on, and it's going to get big, and then they'll take some string and they'll tie, basically tie the radius on to the balloon while this is inflating. And I'll pass around the current to, okay, so these are the 2 radiosondes that are currently in our network. This is made by Graal, which is a German company. This is made by Vaisala, a Finnish company. Here, this is the predecessor to this guy. All right, so actually I'll pass these 2 around. You'll notice this large pack on the back that says batteries in it. And it's quite a bit heavier. And when you think about that there are about 81,000 radiosonde flights per year, and how much the expense of all that, and the gas is one of the more expensive things. We've recently converted a lot of sites to hydrogen to get away from the cost of helium. So going to a lighter radiosonde meant less gas. So I'm going to pass these two around. On each radiosonde has some similar features. So you'll see a little wire, and that's going to be the temperature sensor. It's measured based on resistance. And then on each of the sondes, there will also be little chips. So this chip is right there. That's going to be a humidity measurement. There's also a GPS. So on the one, there's a spiral antenna. That's how they receive GPS. It's going to calculate the winds based off the GPS location. And so again, this is one data point per second received live back on the ground. So it's really kind of fascinating to watch the data come back in. There's a lot of different things that can impact the measurements of any weather sensor. So for the radiosondes, actually for any sensor, it's going to be the solar radiation. So, do you mind if I? For this one, actually for all of them, they would want this temperature boom to be slightly tilted this way so that it gets aspirated quite a bit, and also the impact of the solar radiation is not as bad. So they've designed this little post here. Once you tie the string to the balloon, you tie the string to this little lifting post, and you put it in like this, and it pushes the little boom to the correct angle that the manufacturer wants us to do. That's how it's going to go up in the air. Alright, I think oh yeah, this is kind of cool. Since the late 1930s, the Weather Service has taken upper air observations with radiosondes. Before weather balloons, they used kites with really, really long strength. Yeah, I went to a similar facility as ours in Germany, and they had a little weather museum. And in that weather museum, they showed where all the different kite houses were around the country. And these little kite houses were like round glass huts, and they would spin around as the kite would go around. And there's actually one on Mount Weather. That was the one that was closest to here. I think in that book they had Mount Weather and somewhere in North Dakota too.
And what was the GPS spiral? Was that this? Or?
That was on the other one. I think the GPS, the GPS antenna in that one is internal.
But where's
yeah,
which one can you see?
on that right there, the spiral antenna.
That.
Yeah, that's how that one received GPS. The other ones have gone to a more of an internal antenna, and then the little strings hanging out the end are the transmitter back to the ground. So the antennas are receiving the signal from the radiosonde, so it needs line of sight the entire time. Okay, now we're going to do our last kind of drill down to the facility that I work at and our specific mission. We talked about the facility as you drive around Old Ox Road. So if you're coming from Route 50, if you're familiar with this area, you're coming up this way. It has all changed with a road expansion around here. This is the forecast office that Brandon worked at. This is my office here at the Sterling Field Support Center. There are a few things labeled here that I'll point out. We have a wind tunnel, that's pretty cool. That can reach up to Category 5 hurricane wind speeds. And our goal for having a wind tunnel is not to destroy our instrumentation, but to make sure that the instruments can accurately measure the wind speed and the wind direction.
Have you ever went in the wind tunnel while it's going?
No, they frown upon that. I've been in the wind tunnel, but not while it's on. The only person that there was a reporter for Fox News. I've seen the video of it, but I wasn't there. That had a live shot in the wind tunnel while the wind tunnel was going. I think the government person that allowed that to happen had a talking to. But yeah. We have test pads. So I believe it's 225 little spots here where you can hook an instrument up to that has power and communications, and they're spaced evenly apart so that you can have a test. A lot of what I do is very like basic science. You have your device under tests, and you have something that's a known quantity, and then you compare the two. Or you have two of the same units under test, where you can get a precision measurement. So we're typically looking for accuracy, precision. Is it durable for all types of environments across the US, Alaska, Death Valley, Key West? Autosond, this is where we have our automated balloon launchers. We have two of them side by side. If you've driven around and you see these little domes, those are what the old upper air systems were installed in. So they're like these big parabolic dishes, and they would track the radiosonde as it moved around. Yes.
So when we say like sonde, is that like, can we like guess it's relating to like weather balloons or that kind of
Sonde?
measurement? Yeah.
Yes. Yeah. I mean, in our lingo, we'll just say sonde is like short for radiosonde, but it can also be like a drop sonde. It's a sounding, an instrument for a sounding. Yes. Yeah. So you're focusing on that.
Well, yeah.
Okay. Yeah.
The radiosonde.
Right. Yeah. Okay. I think that's there. So some history behind our facility. I'll just read a few of these paragraphs because it kind of explains. We sort of have the same mission. The date on this was 1979, October 25th. I'll slide over here. I'll start here. What seems like the set of some science fiction movie is actually the Sterling Research and Development Center of the National Weather Service, and the odd assortment of boxes and towers is actually complex equipment designed to measure the weather. The center's existence and purpose seem to be as foggy to the general public as the actual site was on the morning it was visited. I've heard people say it was an underground facility because there is nothing here, said Robert Strickler, chief of the Test and Evaluation Division. People think we're part of the CIA. Actually, the center tests new and previously existing weather equipment and develops weather observing techniques. Once an hour, observations are taken on humidity, atmospheric pressure, temperature, clouds, and precipitation, and information is then sent into a communication network which serves other offices and organizations all over the world. So that once an hour, somebody's taking a weather observation doesn't really happen anymore. I suppose there are a few airports, Brian, is that right, that have weather observers?
Yeah, so actually most of the major airports, they still have weather observers who can take an observation. Yeah. So Reagan National, Dulles, they have folks that are there in the tower that are taking observations.
Right. Most of the observations are now automated. So there's, along with the weather observer, there's also an automated weather system, the ASOS. And that's actually what these folks were developing at the time of this article, was a way to automate surface observations. And later on in the article, they talk about using lasers and how they're trying to figure out a way to identify precipitation type based on the laser. And so that was one of the first instruments that I tested when I got to Sterling, was a precipitation identifier. They called it an enhanced precipitation identifier. It didn't get fielded because it didn't work that well. So yeah, that's from 1979. The article goes on with several environmental chambers. Scientists can subject instruments to all kinds of weather without taking them to the actual environment. So that's a big value in what we do. We have these large environmental chambers where we can simulate all sorts of conditions without having to actually spend the money to put it out in the field. Our mission at the Sterling Field Support Center is to support, advance, and assure the quality of weather observations taken by the Weather Service and other government agencies, to ensure observing systems in part or in entirety produce scientifically and operationally sound data that conforms to national and international standards. So we like to think that we're rooted in observation. Here are our three kind of functional areas that we support our mission. One is in the laboratory sciences. So here's some pictures of our chambers. This is a salt fog chamber. This is a temperature and humidity chamber. This is a small wind tunnel. We have a much larger one. This is an altitude chamber, and that is another temperature and humidity chamber. So along with the laboratory sciences, we also do test and evaluation. So the idea, kind of the flow of things, is to say, all right, how do we know that the temperature is right? And so we have reference instrumentation that is traceable to NIST or traceable to SI units. And we'll make sure that those reference instruments are nice and pristine and kept well. And then we will calibrate other instruments to that. So for temperature, think of a platinum resistant thermometer that's just like a little probe. We'll put those probes in our chambers, and we'll keep this chain of traceability back to our references, and that's how we'll evaluate temperature, humidity, pressure, all that sort of stuff. And to make sure that before the Weather Service buys a large amount of radiosondes, 80-some thousand, or buys a climate system, that the advertised specification on that is actually right. So after we do some indoor controlled tests, we'll then take it out to a field environment. The field environment is way different, not just because it's outside, but also because suddenly you're introducing sunlight, wind, precipitation, dust, all that sort of stuff really plays havoc into taking a measurement. Most of our measurements, we try to associate some sort of uncertainty with them. That's fairly easy to do in the lab. Once you go outside, it's difficult to do that, especially a radiosonde. Having an uncertainty associated with every single temperature measurement is kind of like the ultimate goal, but we're not there yet. And when I say we, I mean kind of as a world, as a community, scientific community, we're not quite there yet. Okay, so once we've tested and evaluated an instrument, and a program manager says, great, thanks for your report that the instrument looks good. I'm gonna buy a bunch of them and we're gonna put them out in the field. So then our team has developed all this knowledge. We'll then support it either in the deployment out to the field, or if somebody has a question, they'll call us. So that's the field support. All right, I'm gonna skip through this one because I think I've already kind of talked about the lab sciences. Here's some of our equipment. Pressure, this is a temperature bath. It's kind of a high-end jacuzzi tub for temperature sensors. If there's some swirling of the liquid in there, and you try to get a homogeneous environment for your temperature sensor to be calibrated. This thing that, I don't know, kind of looks like a brain, or I don't know what it's a bell jar, is our pressure reference. It's a piston gauge. So we can hook up all of these field reference instruments to this very expensive pressure reference and do calibrations. And then a technician will ship this out to all the forecast offices, and we'll say, all right, now calibrate your pressure instruments based off of this that was calibrated to this, and this was calibrated to SI units or to NIST. So that's how we're trying to keep that unbreakable chain of observations. Yes?
Is that a microwave?
This?
Mm-hmm.
This is a chilled mirror. So we're talking about dew point measurements earlier. So the idea of a chilled mirror is to, I'm gonna use our bathroom as an example. We have a mirror over a window in our bathroom, and in the evening, the sun is beating on the mirror from behind it, from through the window, and that mirror never fogs up in the evening because the temperature of the mirror is high. It's higher than the temperature inside the room. So in the morning though, the temperature is low enough that it reaches the dew point of the mirror, so it like fogs over immediately. And that's pretty much how we do dew point reference measurements. This is a chilled mirror, so there's a little surface area of the mirror, and there's optical lasers that will shoot a laser onto the mirror. The light will reflect off of it, and the moment that dew starts to form on that mirror, the receiving end of that laser will know it that there is dew on the mirror, and the temperature of the mirror is monitored, and the temperature of that mirror is then dew point. So it's sort of complicated, but it's in your bathroom mirrors. You've seen the same thing.
You have to be careful with mirrors, because if those little round mirrors point down to the windowsill, you can catch fire.
Oh, right. Yeah.
I've had that happen.
Yeah, I think we've already talked about the different programs here. What's unique about the co-op program, as we go to automation, more and more automation, this one is actually written into as legislation that somebody, an observer, has to be part of the measurement. So that's kind of challenging when you're talking about when you have a sensor that can report automatically. How do you include an observer into that? So that's sort of an interesting challenge. ASOS, this is aviation driven. So an interesting challenge with that was, I don't know, maybe 10 years ago, the temperature sensor at Reagan National Airport appeared to have a high bias, and people in the Washington DC area, a lot of weather people, that's where the Weather Service headquarters are, a lot of people paying attention, and they say, hey, you have a temperature bias, why aren't you fixing the temperature sensor? Well, the reason was because the temperature sensor has a tolerance for aviation. It's actually like plus or minus 5 degrees. So it had, according to Weather Service regulations, that temperature sensor was fine. It didn't need to be swapped out. However, the data can be used for other purposes, such as what's your on the news report. That's where they may pull your local temperature from the airport, not knowing exactly what the tolerances are on the temperature sensor. Oh yeah, and there's the VOS, the Volunteer Observing Ship Program. A ship will volunteer to host a station on it. The biggest hurdle with that is getting the information from the ship to a place that can actually like process the data and incorporate it into models. These are our different chambers. We kind of talked about that earlier. Different capabilities. We'll instrument some of these chambers with different items. So the similitude chamber, the altitude chamber, we'll put a GPS simulator in there to simulate GPS measurements. We'll also put a solar simulator in there that can simulate up to one sun, because solar radiation is the biggest cause of uncertainty in a radiosun measurement. These two are kind of interesting. This is a sonic anemometer, so it's measuring wind speed based on the sound traveling between 3 probes. So each probe will kind of transmit and receive sound. It's a little chirp. And this was supposed to improve how wind measurements were done, because the old propeller measurements, as freezing rain would happen, it would start to slow down. And if the propeller's slowing down, it's still moving, but it's slowing down, you think, oh, the wind isn't as high, but what's really happening is there's freezing rain on it. So here comes the sonic anemometer. We've solved that problem, except if it doesn't have heat on the transmitter and receivers, it won't work. So this model happened to have heated probes. This model didn't. So that was one of the benefits of testing.
I have 2 questions. My first one is, what are they made out of? They're kind of weird.
Well, I mean, this is all metal here, but there's, I guess, heated elements within it, and it uses sound to transmit. It uses the delay in the sound from one probe to the other as a way to calculate the wind speed in one direction.
Like, what's that, like very, very lightish brown stuff like crystals on it?
Here,
No,
on this one, this is definitely ice.
it's ice.
Yeah, sorry, maybe I should have been more. We were spraying the sensors at really cold temperatures to get an ice buildup so that we could see if the heaters worked.
And my next one is, when were they made? Were they made like around the same time or like different times?
Probably within a few years of each other. Yeah. This here is our large wind tunnel. So this propeller is back through that door on that side, and it pulls the wind through from this side. We get to about 160 miles per hour in this small test section here. Here's the example of the propeller that I was talking about as it accumulates ice. Here's some pictures from our test beds. We have cameras in our test beds to help automate our observations and help to troubleshoot if we get a weird observation, you know, what happened. Yeah. Yes.
Have you ever caught an animal on a picture?
Not the test bed cameras, but I think a bear was caught at the forecast office.
There was a bear on the
security
facility that was roaming through the fields there.
Yeah.
They actually walked right by the forecast office. We got pictures of them somewhere. But yeah, there's definitely wildlife out there.
Okay, so in order to do a comparison of instruments, we'll use a crossbar, a styrofoam crossbar, which is this guy here. And then, as I mentioned before, a lot of the tests that we do will be a reference versus the test. So this here was our humidity reference instrument. It's a chilled mirror. And this is kind of the spiel that I said before about using what a chilled mirror does. So this was done at Wallops Island, where we had this crossbar dangling 4 radiosondes from it, plus the chilled mirror, all attached to a balloon. And that was sort of a fun project to do. And I think if this video will play, yes, it will. All right, this came from Reno, Las Vegas, and this is part of like the field support part of what we do. We're deploying a new system out there. And the local observer said, okay, he said to one of my colleagues, he said, when you take the balloon out, this is what's going to happen. It was very, very specific, and as he was going through it, I said, there's no way that this is actually what happens. He said, you're going to need, it's going to get really windy once you get to about like 5 feet. He said, you're going to need to run the balloon out to the edge. He said, and let it go high because there's going to be an eddy that's going to flip the balloon around as you get out to the edge. He said, if you release it too soon, it's going to flip on the ground and hit the ground. So you need to get it to the edge because the ground sloped down. And sure enough, that's what happened. This was the first time I had ever seen a balloon loop before. Yeah. So it didn't. The goal was to not let the instrument hit the ground because then you have a damaged instrument. Yeah, I've never seen that happen before. All right, that is all I have. I rushed through a bunch of stuff so we can take more questions, but I wanted to point this picture out. This was from a campaign in Germany to compare all the world's radiosondes and instrumentation for upper air. So this is taken from what's some sort of GoPro camera probably from on the end of one of these poles on a weather balloon. And you can see 1, 2, 3, 4, 5, 6. There's probably 7, there might be 8 radiosondes on this contraption. And then they will share this data and they be in a comparison with the rest of the world. But it kind of gives you a unique perspective of where the instruments are. You can see the curvature of the Earth. All right.
Were you all involved in analyzing the Chinese weather balloons or surveillance?
We had questions. we received some questions about that. That was a pretty, like we know that our weather balloons go from surface up pretty quickly, and they're not hovering at a certain altitude. So that was a pretty obvious thing to us that it wasn't a weather balloon.
And how high did you say your balloons go?
So the one that we had did I pass it around?
It's over on the left there.
Okay. That goes to about 100, I think it's a 26 kilometers, so about 100,000 feet. We have some bigger ones, like if they, for this one they use one that probably goes maybe closer to 120,000 feet, a bigger balloon.
And they all explode at that height, or do some
Yeah.
explode at higher or lower?
They're actually amazingly good that they explode pretty much all at where they're supposed to, like at maybe 30 kilometers. They're spec to 26 kilometers, but we'll get anywhere from probably from like 30 to 32 kilometers out of them. Yeah. Yes.
So, different countries are, there's the different models on the international kind of field. Do they use their own instruments in other locations, or is all the data kind of either bought or just open access, and then they just apply the different kind of model to it?
Yes, so the goal is for everybody to share their data. And so our data centers, I'm aware of 2. One is part of Weather Service and one is part of Navy. They are like scavenging for data observations. They all have their unique paths, and it is super confusing how they get the data, because there's usually for each center there may be like 3 or 4 different ways that somebody could come into that center with data. So yeah, we're collecting data from all over the world. Other countries are collecting data from us. We're offering it freely out there. Is that kind of what you're?
Yeah.
Okay.
So.
The little like where those letters grew on. Yeah, did they stand for something, or was it just
They do. It's an acronym within an acronym. There's the World Meteorological Organization that kind of is like similar to the World Health Organization, except for meteorology. Within that organization is the Global Climate Observing System, GCOS. This is I think it's the GCOS, I don't know if it's GCOS or just Global Reference Upper Air Network. And the idea behind this, they've gone to extreme lengths to determine the uncertainty of temperature, humidity, pressure, and wind measurements of each radioson. They go to great lengths to do that in order to establish a global reference upper air network that is, the application is specifically for climate monitoring.
Do you help with like the rockets that go into space? Like, do you send information to them?
No, but when we went to Wallops, that one picture was from Wallops Island. That's a NASA center where they do send rockets up. So some of the people that we worked with there, whenever a rocket is about to go up, they will send, I think it's 13 balloons up, maybe like starting at 6 hours before they launch a rocket. They'll send one weather balloon up, next hour they'll send another, and then once they get closer to the window of launch time, they'll start to send, I think it's 3 up, like right before the launch. because any wind shear could be catastrophic for the rocket.
What has a balloon ever like interfered with a plane or like a smooth plane, like a bird?
I am not aware of any plane and balloon issues. So everything on the balloon, including the radiosonde, is within the FAA's regulation. So that's the weight and the makeup of the material. The idea is if a very rare chance that this did impact a plane, that the radiosonde could just go right through the engine and not cause any issue at all.
Or like a bird.
How do they test that?
Well, I'm assuming that they tested that the regulation was created, because I think the regulation is like 5 pounds. You can have a 5-pound payload. I'm assuming that's not like kind of a brick, because a brick would impact. But I don't know how they tested that, if they tested that. Yeah. Did you see something else?
Honestly, what about a bird?
A bird in a plane or a bird in a balloon?
A bird in a balloon.
That's another one that I'm not aware of any issues
Birds
with.
are too smart, they'll avoid it.
There was an instance down in Key West at the office down there. They used to release on the airport property. And so there's a flight train, a piece of string that connects the radiosonde to the balloon. Well, as they were running it out on the airport blacktop, there was a crab decided to grab onto the string to go for a ride. And he went up with the balloon. So it's not a bird, but it is, you know. Yeah.
Did you cut any of the string? Like,
I don't think. I just think he grabbed on for dear life and he just held. I don't know how long he held on for, but
Good thing.
yeah, he got caught in the string.
which campus is?
Any other questions?
Thank you.
Yeah, thanks for your attention.
Thank you all. That was so. When I bugged you about doing this, I was kind of like, everybody loves weather. It'll be super exciting. It'll be great. But it was better than I could have ever anticipated. So I really appreciate everything you guys did and coming out here and sharing. It definitely makes you appreciate it at a whole nother level, all the complexities of all the interagencies and all the things that you have to do and deal with. And I think it's nuts that you have to go through and change your hours all the time. That seems crazy. Like, my mom was a nurse, so if you stay on night shift, your body just you get used to it, you adapt. But to have it on a rotating 3-week basis, whoa.
Yeah, it's definitely it's a risk and it's a known, when you enter into the profession. But like I said, when you're passionate about something,
You want to know.
yeah, you want to be there. You want to be there during the extreme weather events, and they can happen in the middle of the night. So a lot of folks sign up for it.
So, and then we have a math question for the young members of the audience. So if it was average $200 per balloon going up, there's 120 stations to do it at 7 a.m. and 7 p.m. How much is the cost per day? We expect you to know. My guess was $48,000 a day. If it was 200, it was 240 times 200. Is that right? $48,000. That's crazy.
Yeah, and I mean, there's different. So the balloons are going up above the troposphere into the stratosphere, and so there's some good climate data. So the climatologists love having that data up there for the numerical weather prediction. That's the primary way of getting upper air data. So that's the second application for the forecaster. Severe weather, knowing the stability or instability of the atmosphere is critical as well. That's where I get a lot of your warnings from.
There's a lot that the weather instrumentation can capture that satellites can't. You have thick cloud cover. It's tough for that. I mean, it can measure the temperature of the cloud, but below that, satellites have a hard time measuring that part of the atmosphere. So that's where these guys are really vitally important.
For those, we do have some tea that's over there. There's some cookies. There's popcorn that was brought generously by Andrea. If you want to eat some food, and then you can ask questions if you want to Wonderful. But yes, thank you so much. All right, April 29th, Saturday. The next one, speaker series, is going to be birds of